I'm my 6th grade geologist. Welcome back to the last set of video notes in the minerals section. Yay! So these notes are going to be a little long, so bear with me, but I promise as soon as they're over, you won't have to worry about listening to me anymore about minerals. So let's just dive right on in. So how do minerals form? That's our big question for the last chunk of our video notes. How do minerals form? So I already have my date down in my notes, and I'm going to put mineral formation, just so I know that these notes are about the way that minerals form, the formation of minerals. So let's get started. On a rock collecting field trip, you find an egg-shaped rock about the size of a football. Later, at a geological laboratory, you split the rock open. The rock is hollow. Its inside surface sparkles with large amethyst crystals. Amethyst is a type of quartz. You have found a geode, as shown in figure 10. A geode is a rounded, hollow rock that is often lined with mineral crystals. Geologists believe that crystals probably form inside the geode from water containing dissolved minerals, or when water containing dissolved minerals seeps into a crack or hollow in a rock. Slowly, crystallization occurs, lining the inside with large crystals that are often perfectly formed. Crystallization is the process by which atoms are arranged to form a material that has a crystal structure. So, I'm going to stop there for a second. We have two highlighted words we already need to put in our notes. One of them is geode. So, a geode. And let's see, what did our notes say a geode was? A rounded, hollowed rock that is often lined with mineral crystals. Yeah. I can't read today. So, a rounded, hollow rock that is often lined with mineral crystals. So, geode. Oops. So it's believed that these crystals are formed when water containing dissolved minerals seeps into a crack. So let's add that too. Scientists believe geodes are formed when water containing dissolved minerals seeps into a crack or hollow of a rock. So all of you have probably seen a geode before. It's those two pieces. I'll show you a picture real quick. Actually, there's a picture in your notes. There it is. There's a geode. So geodes are really, really pretty. So, let's keep reading. Oh, one more. Crystallization. Crystallization is a process by which atoms are arranged to form a material that has a crystal structure. Crystallization. In general, minerals can form in three ways. Some minerals form by organic processes. Other minerals can crystallize from materials dissolved in solutions. Finally, many minerals crystallize as magma and lava cool. So, organic minerals. All minerals can form by inorganic processes. However, some minerals can also form by organic processes. Oh boy. So right now, I'm thinking in my head, this is kind of confusing. It told us before that it had to be inorganic, but now it's telling me that it can be organic also. So let's first put this in our notes. Organic minerals. So actually, instead, I'm going to put minerals form in 3 ways. And then I'm going to list them underneath. So the first is organic processes. Let's see, what does it say? For instance, ocean animals such as clams and corals produce shells and skeletons made out of mineral calcite. So what it's saying here is that even all minerals can form by inorganic processes, but some can also form by organic. So what it's saying is, like calcite, for example, calcite can form from organic processes, but it also forms by inorganic. You can't have a mineral that only forms by organic processes. So I'm going to make sure I put organic processes, and I'm going to put an example. Calcite can form from shells and skeletons of clams and coral. Just so I kind of have an idea. So let's go back. Organic minerals. Number 2, minerals from solutions. Sometimes the minerals and compounds that form minerals sometimes the elements and compounds that form minerals can be dissolved in water to form solutions. A solution is a mixture in which one substance is dissolved into another. So let's put that in our notes real quick. Actually, let's hold on for 1 second. Let's finish. When elements and compounds that are dissolved in water leave a solution, crystallization occurs. So we'll put minerals from solution. And then underneath that, we'll put a solution is a mixture in which one substance is dissolved in another is a solution. Minerals can form in this way in bodies of water on Earth's surface. But the huge selenite crystals found in Figure 11 formed from a solution of hot water that was cooled underground. So, I'm not really going to touch on these. I'm not going to read them, but kind of some ways that they can form is minerals formed by evaporation. So this is what happens when the water that's in a solution evaporates and it leaves behind just the crystals. So the example that they give is when the water in salt water evaporates, it leaves behind salt crystals. The other way is minerals from hot water solutions. So this is when the hot water can dissolve the elements and compounds that form minerals. When the hot water solution begins to cool, the elements and compounds leave the solution and crystallize as minerals. So, for example, quartz can crystallize at a hot water solution. And this word here, vein, we're not going to focus on that too much, but a vein is a narrow channel or slab of a mineral that is different from the surrounding rock. So sometimes you find like mineral veins, that's what that is. So let's put an example of minerals formed from solution. So we could put example, so we could put deposits of halite formed over millions of years when ocean ancient ocean seas slowly evaporated. So we'll put halite formed when ancient seas evaporated. Formed over millions of years. Oops, put that in the wrong place, didn't I? Formed over millions of years when ancient seas evaporated. Another example, and we'll put one from our hot water. So, quartz can crystallize out of a hot water solution. Quartz can crystallize out of a hot water solution. It's really cool. Pure silver is also often deposited from a hot water solution. Gold, too, can be deposited in this way. So there's also even some more examples of ways that are deposited through minerals that are deposited through solutions. So let's move on to our very last way. Move my notes down just a little bit. Minerals from magma and lava. Many minerals form from magma and lava. Minerals form as hot magma cools inside the crust or as lava hardens on the surface. When these liquids cool to a solid state, they form crystals. The size of the crystals depends on several factors. The rate at which the magma cools, the amount of gas the magma contains, and the chemical composition of the magma all affect crystal size. Magma and lava are often rich in oxygen and silicon. Minerals that contain these elements are called silicates. Together, silicates make up a majority of the Earth's surface. So the last way that we have is minerals from magma and lava. I'm going to add up here, I'm going to change this to minerals from organic processes, just so we keep it all the same. So here you see, here's a picture of minerals from magma. So the difference between magma and lava is magma is what's inside the Earth's crust and lava is what's on top of it. So we'll put, let's go back to our reading for a second. Magma that remains deep below the Earth's surface cools slowly over thousands of years. Slow cooling leads to the formation of large crystals. So let's put that there. Magma deep in the Earth's crust, or deep, we'll put it deep below the Earth's surface, cools slowly to form large crystals. Oops. Example, quartz, feldspar, mica, tourmaline, all kinds of different ones here. So we'll put quartz and feldspar. Now let's go to lava. If magma erupts to the surface and becomes lava, the lava will cool quickly. There is no time for large crystals to form. Instead, small crystals form. So lava, on the Earth's surface cools quickly to form small crystals. Example, olivine. That's a good one to remember. I think of Olive Garden. And we probably should put that minerals that contain oxygen and silicon are silicants. Minerals that contain oxygen and silicone are called silicates. Well, that's the end of our notes. I never thought we'd get here, but we made it. So, now you need to move on to your choice assignment, and then you move on to your scavenger hunt, and then check your understanding. The end is near. You can see the light at the end of the tunnel. So, I'll see you on the flip side.